I'm often asked by teenagers and parents what soldering iron they should buy and what should they pay. The short answer is you should buy the best you can afford. The long answer is that you don't have to spend a fortune to buy a soldering iron that is fully capable of doing electronics grade soldering work. Before we get started, you're going to want to buy a soldering iron stand. This soldering iron stand is available for about 100 rands. It's made of cast iron, so it's quite heavy. And it has a place here for a cellulose sponge. Once you switch on the soldering iron, you'll notice there's a little LED light there, which is quite nice because it'll remind you to switch the soldering iron off. Get in the habit of wiping the tip of the soldering iron on the cellulose sponge every time you pick it up. Then you will make perfect solder joints. Before we get into the details of this affordable soldering iron, if you can afford it, I would recommend you buy a high quality soldering iron station like this Magnum model with a digital temperature readout. An iron like that will cost you about 2,000 rands and you might use it for the rest of your life. Today we're going to take a detailed look at this soldering iron that actually came in a kit with some soldering tools. So having switched this iron on, it seems to be running pretty hot. Now this is no clean fluxed soldering wire, 0.9 millimeters the thickness I favor, though there is 0.7 and 0.5 available from Mantech. They do sell a small roll for hobbyists. This is 0.5 kilogram of solder which will last your club or school many years. My first reaction to this iron is it looks pretty hot, and if I touch this soldering wire, it seems to vaporize, so it's making a lot of smoke and it's almost vaporizing the flux in the solder. So this iron, according to me, is running very hot. And if you look at the tip through this small magnifying glass, it looks almost blue. The solder doesn't take on the tip, it seems to vaporize. So the first thing I'm going to do is I'm going to adjust this dial down quite a lot and see if the iron gets too cold. So what you'll notice is there's a little index mark there. So you will see that I've dialed it down and now the tip is starting to look a bit shiny. This iron still seems a bit hot, but you'll see that the iron has cooled down a little bit. Learning to solder is a very practical thing, and you actually need to get a hold of a decent soldering iron and you need to experiment until you find what works well. But having dialed this iron down, it's still a very hot iron. Now you don't want a cold iron. If you have an iron that's too cold and it can't heat anything up, you will tend to get big half-melted blobs of solder building up on your circuit board, and that's not a good thing. What I'm doing here is I'm just melting solder onto the tip, and you'll see we've got a bit of a shine in the tip. Something on the tip there. I think the soldering iron is still a little bit on the hot side, so I'm going to dial it all the way down. We have this iron on its coolest setting. I put quite a lot of solder onto the tip, trying to get the tip perfectly shiny. With this close-up video, let's have a look at what's happening. And this soldering iron, we just powered it up a few moments ago. It seems to have a bit of a blemish, let's call it a blemish, over there, which is not ideal. So if the tip of your soldering iron is quite dirty, just give it a wipe to get rid of everything. It's quite clean, but there's definitely a blemish. If you wipe the tip of the iron in the middle of the sponge, all the stuff won't wipe off the tip. When you wipe the tip of the iron on the edge, the stuff falls down into that open area. So we dialed this temperature right down, and now it seems to be working at a more comfortable temperature, so it doesn't instantly vaporize the solder and the flux, and the tip of the iron shouldn't be blue with heat. This hot iron might be quite well suited for lead-free solder, which you need quite a hot iron. So that's a good thing. I'm going to change the tip. Now make sure this is cool when you touch here like I'm doing, and remove this carefully. You'll notice this metal has kind of gone a bluish color, which indicates tremendous heat. Be very, very careful with this white ceramic heating element because it can break very, very easily. A bump, or if you put a tip on roughly or carelessly or bend things, it can crack, and then the iron's probably going to stop working. I think we should try this point next. Okay, so put that there. Let's tighten this up slightly. This is heating up again. We're keeping the iron on its coolest setting, and let's bring a bit of solder along here. Because the iron is on a colder setting, it does take a little bit longer to warm up, but then at least we don't turn the point blue. This was the one that we had in the iron when we started the iron for the first time, and we turned this point blue, and we may have burnt the tip a little bit. This point is definitely looking sweet. It's quite fine, it's quite sharp. Now if you spend the money and you acquire a soldering iron with a digital temperature readout, when the solder is reacting like this, you're probably sitting at about 350 or 360 degrees. So I don't think this is a reliable indication of temperature. I think this just turns the power to the heating element down. Okay, that's a really shiny tip. That's really clean, and I can't see any burnt black marks, which we had on that first tip that we probably overheated accidentally. So if we look at that point there, that is really good. This iron is able to heat up quite big joints. I quite like this tip. The next test we can subject this iron to is we can make up a circuit board. This is the 6 phototransistor sensor. You'll see that I've placed the phototransistors. I'm just going to solder one of the legs. So just on the one side, soldering it. Don't solder both legs of the LEDs unless you've press-sticked them exactly in the position you need them to be in. Because once you solder both legs, they're not going to move. They're almost randomly situated, but that's fine. Because I'm going to hold the board with its one hand, and with one finger, I'm just going to lightly press on the part and melt that blob of solder and push the part where it needs to be. And this is a great way to test the abilities of a soldering iron. So we want to melt that and make sure that it's lined up straight. And so we do with all of these LEDs. We heat that LED up a little bit and we push it into position. We can clip these pins off nice and short, like so. We can pin this board down and we can just complete the soldering process. I'm going to jump in there with the soldering iron. You've got a beautiful close-up view of what's going on. And you'll notice how quickly and efficiently we can finish making these joints. Notice how well this iron works. It's got a great hand grip here. It's got a few spare tips. We burnt this tip a little bit. You can see it's kind of blue. Hotter isn't always better, okay? So the right temperature is not too hot, not too cold. Too cold, the solder goes into lumps. This soldering iron doesn't seem to do too cold. Too hot, which the soldering iron did when we first switched it on at the halfway mark, got very, very hot and started to play a little bit with the tinning of the tip. So you want to dial this thing down, and then it's a very workable soldering iron. In conclusion, this is a soldering iron that I can recommend to my students. That comes with a few qualifications. The first qualification is that you're going to need to turn the temperature right down on the soldering iron before you ever switch it on. The second recommendation is I would actually remove this dial here if I were using this soldering iron in a school or club situation to prevent the dial from being accidentally turned up and damaging the iron or damaging the robot kits. So you just basically hook your fingernail under that little control and you'll see there's a variable resistor over there, and that's fine. Now it becomes quite difficult to change the temperature of the soldering iron. The next conclusion I reached about this iron is this temperature control. It's not really a temperature control, it just turns the heat of the iron down, but there's no relation between what's on the dial here and the actual temperature of the iron, which gets incredibly hot. Another recommendation, don't leave this iron running. You're probably going to end up ruining the point, and it's dangerous. You can end up causing a fire. 450 Rand for this set of tools and this little soldering iron is good value. It's probably worth 800 Rand what's here. If you're on a strict budget, Mantech has promised to make just the iron available for just under 200 Rand. And I think that's the deal I would go for because I don't need these tools in the kit. If you acquire one of these irons at 200 Rands, that's a good deal. Finally, please don't be tempted to buy a soldering iron from your local hardware store. The way you know you're dealing with a hardware store type soldering iron that's going to run way too hot and damage your robot electronics is you will see, as in this little drawing here, there's normally a little screw that holds the point of the iron in there, and the point of the iron looks like a roof nail, and after just one session it will go blunt and form pits on the end of the point, and it's only marginally cheaper to buy a hardware store soldering iron than to buy one of these proper electronics capable soldering irons. Take a screenshot of a close-up of this iron from the video, print that out, take that with you when you go to buy the iron, and don't be fooled by a slick salesperson who tells you the iron that they're selling you is the same as the iron in the picture. If it doesn't look exactly the same, it's quite likely that you're wasting your money. The problem with buying stuff online is it might arrive and you might find out that it's a 110 volt iron intended for the United States market, and then you're going to sit with a problem of you're not going to be able to use that iron in South Africa with 220 volts.